Hey guys, it's Mr. McMahon and I'm back in the kitchen here doing a little science experiment. And you can see I'm working with Ivory soap today. And Ivory's a little different from most soaps. Another experiment you could do is, as you can see on the label here, they're showing you that Ivory soap floats. Most bars of soap sink in water, but Ivory floats. And that was kind of their marketing. They wanted to be different, and they said, "Oh, look, the soap that floats. Oh, it's so pure it floats," and all that kind of stuff. And in reading my book here, it's pretty funny. It actually said that the reason why Ivory soap floats is there was a man a long time ago who was responsible for mixing it up, and he left the mixer on when he went to lunch for some time. And it got mixed a lot longer than it was supposed to, and it whipped a lot of air in it. And that's why it floats, is it's less dense because there's more air in there. Little air bubbles are in there. And that kind of leads to what we're going to do today. We are going to put 1 bar of Ivory in the microwave. And supposedly what's going to happen is, because there's air bubbles in this soap, and there's moisture in this soap, when we heat it up, the water or moisture that's in the soap is going to turn to steam. It's going to turn to the gas form of water, which is steam. And the steam is going to take up more room than it does when it's just water. Because when it's going to expand as it gets hot. And when it expands, it's going to change the shape of this soap. So let me follow the directions here. Speaking of fractions, they say they want it cut into 4 equal pieces here. So I'm going to do what we've been doing all quarter. To get quarters, I'm going to try to cut it in a perfect half. You don't see the air bubbles, but it's definitely light. It feels less dense. Oops, it's falling apart already. So I'm going to cut those halves in halves now. So I'll cut it. There's 2 quarters. And there's 2 quarters. Boy, does it smell good. I like that smell. The Ivory smell. And I'm going to put it on a plate. Let's see. I'm going to use a big orange plate here. I'll leave some room in between. I'll put that on there like that. Now I'm going to put it in the microwave. So maybe I should spread it out more. Let's do that. We'll spread it out. And it says to put it on high for 1 minute. So you guys ready to watch this? Let's see if we can get in here. So supposedly the soap should be changing shape as the air pockets and the moisture in them. The moisture changes, gets hotter and hotter. Ooh, I see it bouncing around there, moving. Oh yeah, this is cool. Oh my god. Oh wow, this is even better than advertised. You can see the soap is just bubbling up. It's getting much bigger than it originally was. It kind of looks like a huge kernel of popcorn just exploding here. So let's see, we got about 20 more seconds. Whoa. That is awesome. It's about to, this was a full-size plate, so that rather large dinner plate, and it's actually overflowing off the plate now. So my wife is going to love that. The microwave's a mess, but hey, it's soap, right? So how messy could soap be? Holy cow, look at that bad boy. So that was a bar of soap. Oh, now it's kind of deflating. Holy cow, let me take this out here. Man. Just to give you a size reference here, I think I might have overcooked it. I'm going to try one for 45 seconds and see what happens. Well, here's the bar of soap. Oh, man, that is all weird. And the coolest part is you can still use it. So the science book, my buddy Steve Spangler said, just take it in the shower and rub-a-dub-dub, and that's soap. That one might be overcooked. Let's try it again. This time I won't go the full minute.